carbon dioxide, and climate change. Humanity is much more vulnerable than we think. Just a certain increase or decrease in global temperature and all our lives will change dramatically. In the course of natural history, such climate shifts occurred at many occasions, triggered by meteorites, volcanoes, variations in the Earth's orbit, continental drift, or changing sea currents. Often these climate shifts eliminated the organisms dominating Earth prior to the event. There has never been any organism dominating Earth as much as we do. There has never been a species which conquered the planet so successfully and proliferated so massively. Nor has there been a species which has modified and exploited global ecosystems to such a high degree. Thus, we have become an important factor threatening the stability of our livelihood. Meteorites or volcanoes will probably not harm us. The catastrophe we have to protect us against is man-made. Atmospheric levels of carbon dioxide are good examples for this degree of human impact. Until very recently, these levels closely followed global temperatures in the course of glacial periods and warm intervals. Starting 200 years ago, atmospheric carbon dioxide has risen sharply, exceeding by more than 30% levels from past warm intervals by now. This rapid rise has been caused primarily by burning of fossil fuels and by deforestation. Due to the greenhouse gas carbon dioxide, our atmosphere dissipates solar heat more slowly into space. Additional amounts of carbon dioxide therefore refer to some extra heat for our planet. What are the consequences of this extra heat? How will our planet react to this disturbance of its heat balance? How can we find out? For a classical experiment, we would need about 10 identical planets. We would increase carbon dioxide for 5 of them and leave it at pre-industrial levels for the rest. Such experiments are impossible, of course. Predictions can therefore only be obtained from theoretical models. Such models are set up by expressing all processes relevant to climate in mathematical terms and combining them in a common network. Models can be improved by calibrating with information from past climate systems and changes. Given complexity of reality, however, predictions are always partially defective. To me, the general insights of scientists into climate regulation are much more interesting than individual predictions. An important feature in this context are feedback loops. Let's take an example. Warm intervals have been triggered by increases in the available sunlight in the past. This additional amount of energy resulted in global warming of our planet. Warming of oceans decreased their capacity of taking up carbon dioxide, ultimately leading to the release of increased amounts of this gas into the atmosphere. The resulting greenhouse effect additionally increased global temperatures, further increasing the release of carbon dioxide from the oceans. Such a positive feedback loop is also called vicious circle. Further examples for vicious circles are a decrease in the reflection of light by ice sheets upon melting, resulting in additional warming and further melting. Thawing of permafrost soils or instability of marine methane hydrates may have similar effects. In both cases, increased amounts of the greenhouse gas methane would be liberated, resulting in further global warming and further thawing of permafrost or instability of marine methane hydrates. Fortunately, besides these positive feedback loops, there are also negative loops. The global increase in carbon dioxide often results in an increased activity of vegetation, leading to an increase in carbon dioxide fixation and to a decrease in this greenhouse gas. Such negative feedback loops stabilize global climate over longer periods and buffer minor disturbances. As mentioned before, there were many events in the course of our planet's history when buffering capacities were unable to cope with disturbances. Such events triggered positive feedback loops, resulting in rapid shifts in climate. How big are the thresholds for triggering? Which disturbances are allowed and which will lead to irreversible catastrophes? These are urgent questions to current climate models, questions which can only be answered with a large amount of uncertainty. Bottom line, human activities have slingshot carbon dioxide levels far above anything experienced during the past million years. We are only just beginning to understand how this will affect our livelihood. Given our ignorance and vulnerability, we should take any measure to stop this dangerous development.